Okay. Okay, so lesson 13, electrostatics. All right, so I think for the most part, guys, especially for the sake of time and upload speed for you, I want to make these like as short as I can. So a lot of these things, especially this one, is optional, right? So I'm going to let you guys read through some of these. I'll just talk maybe a little bit about the gist of it. So the idea is people were starting to realize things about, you know, like static cling, that kind of stuff. You guys probably experienced that in your own life, right? Where the sheets kind of spark and things like seem to attract each other. So people were noticing the same thing. And this was them trying to figure out like, what is going on? What is that? What's that like weird force that's pulling things together, right? So they had different ideas here. So I'll let you guys kind of go through some of these different theories and read through them. Where's the next one here? Come on, load. There we go. So, did I skip a whole one? Yeah. Okay. So one kind of neat one to kind of mention though was that Benjamin Franklin, the guy who was with a kite and the electricity, the same guy, right? One of the American founders. He came up with a theory that it was called like the one fluid theory, and really both of these, you can read through these. It is optional, but they're based on the idea at the time was scientists like Bernoulli and Euler were coming up with a lot of theories on how fluid dynamics works, and they were working really well. So these other scientists were starting to like use something that seemed to be working really well, and they're like, well, let's apply that. Maybe that works, right? So they started to come up with these different fluid ideas. They're saying that, Benjamin Franklin said that substances became charged because of a transfer of electric fluid when they rubbed against each other. So when I rub, let's say, these two objects together, right, that one of them is actually giving the other one fluid, right? And that was the idea. Turned out not to be right, but we'll go into that one. So modern day theory. All right, so here's the idea, and some of you guys have even taken chemistry, right? And so this will make a bit more sense. And I'm going to jump ahead because at this time they didn't know what we're going to talk about with chemistry. But you guys probably know that with an atom, you've got the proton. Let's say it's just helium. This wouldn't be right because helium will be a gas, right? But let's say you just got helium, so you got a proton and you got the electron going around the outside, right? Well, you guys probably know that protons are positive and electrons are negative, right? Like you learned that in Science 10. Some of you guys taking chemistry, so you definitely know that. And really, that's what's going on here. It's the charges from a proton and an electron. Those are what our electrostatic charges are, right? So we actually, if something ends up having a whole bunch of electrons, right? So if we get some substance and it has extra electrons on it, what do you guys think? Can you in the chat there, can you tell me, what do you think it would be electrically charged, or sorry, negatively charged or positively charged? If it had extra electrons, what do you think? Oh, I can see the chat. All right, good. Yeah, getting the right answers. Negatively charged, right? That's right, because electrons are negative, right? So that's really going to be the gist of this. So one idea here, main one, really big one, right? It's not really hard to remember, is the law of charges, and it's like charges repel and unlike charges attract, right? What that means is if I got two negatively charged things, right, two electrons, let's say, they would repel. They're like charges. They would repel each other. If one of those things was positive, right? So if I had an electron and a proton, let's say, those things are going to attract, right? So that's all that's really saying. It's easy to remember because it's the same thing with magnets, right? You guys are probably used to that if I had two magnets and this was a north end and this was a north end, those things repel, right? They're the same, so they repel. If that was a north and a south, so opposite, they would attract. Okay, so I'm not going to spend too much time on that. Conservation of charge. Conservation of charge is just saying, really, you can't lose electrons, right? So if I started off with a certain number of electrons, I end up with that same number of electrons in the end. Like you're just not gaining or losing electrons or protons. The total protons and total electrons you had at the beginning is the same at the end, right? All right, measuring charge. So the unit for charge, you guys haven't seen this one. It's called a coulomb. And the symbol for it is going to be Q. So the symbol for charge is going to be Q. And the unit will be C for coulomb. So you'd say something like something has, typically it would be 3, micro coulombs would be typical, but maybe something had like a lot of charge would be like 3 coulombs. Okay. So since the proton cancels an electron, a coulomb of negative charge is equal to the combined charge of that many electrons. So the charge on one electron, we're going to get into how they figured this out, but the charge on one electron is going to be negative 1.6 times 10 to the negative 19 coulombs. You guys are going to use that number a ton. It's on your formula sheet. So when you're doing these questions here, if you have it beside you, look at that formula sheet because you're going to be using that quite a lot. All right. So this number, this 1.6 times 10 to the negative 19, that's called the elementary charge. And especially when we get into quantum mechanics, we're going to talk a lot about that. We'll talk a lot about it now, but really the reason why this is the elementary charge is because that's the smallest charge that something can have. And that's literally, if I have one electron sitting there, that's the charge of one electron. So one electron has this charge. And I can't have less than that. I can't have something with a half of that. I can't have something with like any fraction of that number. That's the smallest charge that anything in the universe can have. Which is, starting to hint towards this idea of quantum mechanics. That's a quanta. That's a individual thing. You guys have any questions yet? Give me a thumbs up if everyone's happy. Okay. Oh, Brett's not happy. All right, so big concept here is that it's the electrons that move, not the protons. Okay, so let's say, well, you know what? I'll let you guys look at. We're going to give a bunch more examples farther down. I'm gonna move on and get you guys to read through some of those. So one idea though is that we've got these things called conductors and insulators. Really, the main idea there is that conductors, you probably already know, conductors are good at conducting electricity. Insulators aren't. So a conductor, let's say I have a conductor, right? And I've got, evenly spread apart, protons and electrons all the way through this thing. Well, what a conductor would do is it would allow the electrons in this thing to easily, right? Let's say I brought a negatively charged thing up to this, right? Well, if this is a negatively charged thing and I bring it close to this rod, well, what's going to happen is that all these electrons that are in here, like that one, that one, that one, and that one, they're all going to get pushed this way. And in a conductor, that's going to happen really easily because electrons can move really easily in a conductor. If we had an insulator, it wouldn't happen so easily. They wouldn't all shuffle over to one end of the object as easily. All right. So yeah, I'll let you guys kind of look through those. All right, electroscopes. So lots of our questions deal with electroscopes. So what an electroscope is it's a way of determining if something has a charge. It's not good really at all at figuring out what the charge is, but we can tell if something has a charge. So I'll show you in a second what they look like, what it really looks like behind me. But there's two types. There's going to be something called a metal leaf or a leaf microscope or electroscope, sorry. And we've got what do you call it? This one. What is this one called again? Anyway, this style. And it'll make more sense, I think, when I show you what's going to happen. Yeah. So here, I'm going to go down and give you guys some examples. I'll show you that one in a second, I think, because it'll come up with our different types of charge here in a second. So you guys are responsible in this lesson. There's really no math at all. It's a lot of theory. It's pretty much all theory on like what's actually happening to give things charge. So like you need to make sure these different concepts, like here's the first type of charging. You guys are going to need to know this. So number one, charging objects by friction. Okay. So charging objects by friction, pretty straightforward. If I have, you know, let's say this is an ebonite rod and this is a cloth, right? If I rub these things together, well, what's happening here is that, well, this is an ebonite rod. So ebonite rods, they hold on to electrons really tightly, right? So they don't want to, they want to get rid of their electrons. So here, I'll actually show you here in a sec. Sorry, I'm jumping around a little bit. I kind of skipped one. Where was it? Oh, maybe it. Oh, it's sorry. No, it's below. Sorry, guys. All over the place. So this is an ebonite rod that I'm holding. So this one here. And it holds on to electrons tightly. So if it holds on to electrons tightly, what kind of charge do you think, like if I rub this thing together, what type of charge do you think this ebonite rod is going to have? So just think about that for a second. So it holds on to its electrons tightly. Maybe put it in the comments there. All right, see. Anyone get it? I got negative. That's right, right. So like what's happening here is that this cloth has a bunch of electrons on it, and this has electrons on it too, but it doesn't want to give them up, right? Well, what's going to happen is the electrons from this cloth, I'm just pretty much rubbing them onto the rod. So now you can imagine if you had like really good vision, you could see a bunch of like little electrons all stuck onto the end of this thing. So this thing has a negative charge now. So if I bring this close to something, it should, you know, attract or repel, you know, different things. So so that's one thing. So here, that's the ebonite rod. The other one is my glass rod. So if I rub this one, glass rods, you can see according to this table, they hold on to electrons loosely. So what type of charge will I end up giving this rod? Well, it's going to end up being positive now because all the electrons on the rod, like I'm wiping the electrons off of the rod onto the cloth. So now this thing is left with a positive charge because it has less electrons on it, right? So that's a positive charge. Okay, so that's the idea. That's charging by friction. All right, so now induced charge separation. So I'll show you how the electroscope works here. Stop sharing my screen. Okay, you guys can see me, eh? Is my screen like the main screen on yours? Should be good. All right. Here's the idea. So I've got my electroscope there. Here, see a little better. And what I'm going to do, I'm going to charge this rod, right? Giving this thing a negative charge. And what I'm going to do here is I'm going to charge this thing by induction. So when I bring this close, what's going to happen here? Can you see that thing's actually moving? I'm hoping you can see that in your screen there. Where when I bring it close, it ends up bending away from it or swiveling away from it, right? So what's happening here is that there's a bunch of electrons on the end of this thing. There is electrons and protons throughout this entire electroscope. But what's happening is that since this is negative, I'm pushing all of the electrons down into the electroscope. So now this thing is negatively charged, and so is this little rod. That's negatively charged as well, right? They're both negatively charged. So they don't like each other, so they spread apart, right? They go away from each other. So this is telling me that it has a charge, right? So now I can't really tell much more than that other than it does have a charge. I can't really go by like, you know, the numbers on the side. That's not really telling me much at all because, you know, maybe I just didn't give it as much of a charge when I rubbed it, but I don't know what angle equates to what charge it has, right? But one thing I want you to notice, so that thing was negatively charged, right? Well, this glass rod is positively charged, and you'll see when I bring it close. Oh, here, let me get that ground this thing. When I bring this close after I charge it, hopefully, The glass rod doesn't seem to work as well usually. When I bring this close, oh, it's not going to work for me. Well, it should do the same thing. If I had something better than this actually for the glass rod, you would see the same example. I had it working before you guys came. Anyway, but you get the same effect that we had before. Which in this case, what's happening with the positive rod? Well, with the positive rod, so remember now, this thing has less electrons on it. So it's like, it's positively charged, right? So you got a positively charged thing. And what's happening now is all of the electrons will be attracted. They'll be drawn up toward the metal rod, right? So all the electrons, yeah, will be drawn up toward the metal rod, leaving the bottom positive, right? So they're all pulling themselves up. Now all the electrons are sitting up here, which makes the bottom of this thing positively charged. So now that positively charged thing and that positively charged thing, right? Both of those pieces don't like each other, so they spread apart. Does that make sense? Can you guys give me a thumbs up if any of that made sense? Yeah. Okay, cool. Okay. Next one, while I just have you looking at demos, the next one I want you to see is you can do the same thing with what's called with a pith ball. It's called. So you can see I'm just dangling this pith ball here, and if I bring this thing close, oh, there, I gotta start over. I ended up touching it, but I don't know if you were able to see that they actually attract it as well. So right now, this pith ball is neutrally charged. It doesn't have a charge on it. This thing is negatively charged, right? This ebonite rod. So when I bring it close, well, it ended up pulling in toward the pith ball. I'll talk in a second about why now it's deflecting away, right? Like it's moving away from it. It's actually kind of cool, right? It's like magic. But I'll show you on the screen there in a second why that's happening now. So, all right. Oh, you guys can't see my screen, can you? One sec. Okay. So that's what's called induced, that first one, right? I was doing there, right? Induced charge separation. Now, this is a picture of a metal leaf electroscope. It's the same idea though, right? So you can see right here in this diagram too, that when you bring an ebonite rod, something that's negatively charged, those little dashes are all like, whoop, I'm kind of glitching here. Those little electrons on there or those little dashes are electrons on the ebonite rod. So when I bring it close, it's pushing all of the electrons down into the metal leaf, which causes them to separate, right? There's more electrons on either side of this thing, so they don't like each other. All right, so then when the rod is removed, I didn't talk about that. When the rod's removed, everything goes back to normal, right? Because it's not pushing those charges down to beside it then. Okay. Yeah, I'll let you guys read through that note there too. That'll be important. So read through that one. No, my computer's not happy. Come on. All right. All right, so now with the pith ball, this is just showing the same thing. So again, I'll let you guys look at why that's the case. You guys can read through that one, look at the pictures. But that's why it was attracting, right? In this case, was that you had a positively charged thing. This would be like a glass rod. And all of the electrons, you see how they all shot over to the side of this thing, right? So that's why they're going to be attracted now, is because now the electrons are closer to the protons, which causes those things to attract. So even though this pith ball in general is a neutral object, the fact that all of the electrons are over to one side of this thing is making the positive and the negative of this thing attract. So now they're going to be pulled closer together. Okay. So charging by contact. So charging by contact is actually a pretty easy one. What's happening here? So this is like our pith ball, right? So if we had our pith ball there, and let's say that this object had extra electrons on it. Well, what's going to happen is all those electrons are going, when they touch, right? Here, I'll show you that demo again. I think I'll just show you what's happening when they actually do touch. It'll help. Okay. So when I have my pith ball, right? So what's happening? Remember, this thing is negatively charged. My ebonite rod is negatively charged. So when I bring it close, right? Originally, it's going to like attract to it. Oh, it didn't work very well there. Okay, one sec. I think I grounded something. We'll talk about grounding here in a second. When I bring this thing close, it's going to attract, and then it's repelling, right? It's pushing away from it. Well, what happened as soon as they touched, right? All of the electrons off of my ebonite rod all jumped onto the pith ball. So now that pith ball is negative. So now this thing's negative and my pith ball is negative. So what would you expect to happen? Right? They're gonna repel each other. They don't like each other because they're both negatively charged. Negative things repel each other. So that's a simple one, right? Just the electrons just jumped from one onto the other. So that's charging by contact. Okay. Share my screen again. All right. Now, what happens when they actually touch is, let's say that we've got, some object with positive 22 charge, and this one had positive 8 charge, and then we brought them together. So what would happen there? So think about what is happening. So this first one, right? The fact that it has positive 22 charge, what that means is it has 22 more protons in the end, right? So the way that happened, though, remember, is that means that we lost 22 electrons, right? That's really what happened there. But in either way, in the end, we ended up with an extra 22 protons, an extra 8 protons. So what's going to happen once we bring those two things together, they're going to evenly distribute. So all of the electrons and protons are going to go equally to either side. And then, so 30, like if it was one thing, there was just a positive 30 charge to begin with. And then when we take them apart, they split into equal categories, right? So now it's going to be 15 and 15 once you bring them together, right? So that being said, if you get objects with different surface areas, so because all the electrons are all being stuck on the surface of these things, right? So if this object had twice the surface area of this object, then when you pull them apart, like in this case, when we pulled them apart, they each got half. When you pulled these apart, the one that had twice the surface area would have twice the electron, or twice the charge on it, sorry. Does that make sense? Ish? Okay. Okay, now, charging by induction. This is always the one that's a little bit more confusing to think about. So I'll show my screen again. So you guys are going to have to, on the assignment as well, know these steps. You'll actually have to know these steps for each of these 3 things I'm going through. So here, I'll bring up my screen again here. Okay. All right. Hopefully you guys can see that. Here, maybe I can, no. All right. So induced charge separation. So what we're going to do here, I'm going to give this ebonite rod a negative charge, right? So this thing has a negative charge. What I'm doing here, though, is I'm going to bring this thing close, right? And just like before, right? You can see there's a little charge happening on that thing. It's bending away from it. It's giving it a charge. But now what's going to happen is if I bring my hand over, right? And because like what's happening here is I'm pushing all of the electrons into this thing, right? They're not happy. I'm like forcing them down into the bottom. So what I'm going to do is I'm going to use my hand and I'm going to give them a way out. So I can touch really anywhere on here. And I'm going to touch probably just right here. And what just happened is all of those electrons all jumped across my hand through my body into the ground, right? They literally went into the ground. That's why it's called the ground, right? They went through me into the ground. They wanted a way out and I gave it a way out, right? So that's what just happened there. And then watch what happens now. When I bring my rod away from it, that I've actually given it a charge. Like I'm not even by it anymore. And it now has a charge that was left on it. Anybody want to take a guess at what kind of charge this thing has? So remembering this thing was negatively charged. And I'm asking you what type of charge is left on that electroscope. So I'm going to give you guys like a minute there just to think about that. and then I'll let you know. So think about it, and then can you comment in the chat there what type of charge you think it has? Here, look the other way so you can see it. Here, actually, you know what? While you're thinking, maybe I'll just do it again so you can see what happened there. So here, so the idea here was negatively charged rod. I bring it close, right? So I'm deflecting it. And then, so those electrons are not happy. They want out, right? So what I'm going to do is I'm going to give them a way out. So I'm going to give them a way out. So those electrons all traveled through me, right? I gave them a pathway out of this thing. Everybody's happy. I take my finger away, right? And then I take the rod away. It wasn't as good that time. It does have a charge, but it wasn't as good that time as it was the time before. So what kind of charge do I have? So here, let's see what you guys think. So chat, positive, positive. Yes, you guys are right. That makes sense, right? It's positively charged because I stole, the electrons went through me into the ground. So it was left over with extra protons, right? So that's the idea. It kind of sucks. This is usually a good one that you guys could be here and like actually do it. It makes a lot more sense, I find, when you do it, but you know, circumstances. So yeah, so that's the idea. Something similar can happen with a positively charged rod. So in this case, right? So here's what we just looked at, right? It's, you know, different electroscope, but it's the same idea. So you bring the rod close. This one's on the bottom. I have mine on the top. Doesn't really matter. What happened is it pushed all of the electrons up to the top, right? They all wanted out. I had my hand, I brought my hand close and I touched it, allowing the electrons to leave me and go into the ground, right? And then I take my hand away and it ends up leaving a positive charge. Okay, so the other thing that could happen is that we bring a positively charged rod close. So like a glass rod, right? Now what's gonna happen is that this thing wants electrons, right? So it's like a vacuum where it's like pulling a bunch of electrons down into the bottom. So it wants electrons. So in this case, the opposite happens. My hand touches it. I bring my hand close and it actually draws electrons out of me and into the electroscope. Does that make sense? So this one was pulling electrons out, right? This one was pulling electrons in. So in this case, once I did all those steps and let it go, what type of charge would it have? I won't get you guys to type it just for time, but it'll end up being negatively charged, right? I had extra electrons that all got pulled into this thing. So now when I, you know, take my hand away and then take the rod away, I'm going to be left with negative electron or negative charge left on that thing because it has more electrons. Okay. All right. So that's it, guys. All you guys have for the next class there is the pre-investigation hand-in assignment. Typically, you would do these, and then I'd have you guys do these activities because I actually have these things. We're not going to be able to do the activities, so all you guys are doing will be these ones. Does that make sense? All right. So I think